Hello and welcome to Uncle Matt Online Academy. In this lesson, we want to study independent and dependent events. This is a continuation of our discussion on probability. We have introduced the concept of independent and dependent events in our previous lessons, and we said that an independent event is an event in which the outcome of one of the events is not or does not affect the outcome of the other events. For instance, if you are playing a board game, Ludo, and you have five in one toss, you throw your die and you get five. If you throw the die again, the 5 you get in the first one will not affect the result you get in the second one. That is an independent event. When the result you get in the first event cannot or does not affect the result you get in the second event, we call it an independent event. We gave so many other examples in the previous lesson. So, but for the purpose of calculation, we are going to be using the die as our example here. Also, when we throw a coin, if you throw it the first time, the probability that you get head in the first one cannot affect the probability of getting head or another event or another outcome in the second toss or the second throw. So it does not, the first one cannot affect the result you are getting in the second one if you throw a coin. So this is an example of an independent event. When the result you get in the first one does not affect the result you get in the second one. Now, the expression that we have for independent event or the formula for independent events is probability of A and B is equal to probability of A times probability of B. What this means is this, that the probability of getting A in the first event and getting B in the second event is equal to the probability of getting A in the first event times the probability of getting B in the second event. Independent event is always joined together with and. Both dependent and independent events are always joined together with and when you see and in probability, it always translates to multiplication. So A and B will give us A times B. Now let's see some examples. A die is tossed twice. A single die is tossed twice. What is the probability of getting 5 in the first toss and 3 in the second toss? Now we know that the probability of getting any number in a die is 1 over 6 because there are 6 sides in a die. So the probability of getting 1 is 1 over 6. The probability of getting 2 is 1 over 6. The probability of getting 3 is 1 over 6. Any number you want to get in a die, when you throw it once, the probability of getting it is 1 over 6 because it has 6 sides. So the probability of getting 5 is 1 over 6 and the probability of getting 3 is 1 over 6. This means that when you throw it the first time, the probability that you get 5 in the first toss is 1 over 6, and the probability that you get 3 in the second toss is 1 over 6. Now, since this is an independent event joined with AND, the probability of getting 5 and 6 is equal to probability of getting 5 times the probability of getting 3, which is 1 over 6 times 1 over 6. This will give us 1 over 36. That is why this is the answer. Example 2. What is the probability of getting 3 5 when a die is tossed 3 times? Probability of getting 3 5s when a die is tossed 3 times. When you toss the die the first time, the probability of getting 5 is 1 over 6, following what I explained earlier. When you toss it the second time, the probability of getting 5 is also 1 over 6. And if you toss it the third time, the probability of getting 5 is also 1 over 6. So since these events are connected with AND, we use multiplication, which is now that the probability of getting 5 and 5 and 5 is equal to 1 over 6 times 1 over 6 times 1 over 6, and that gives us 1 over this gives us 1 over 317, 1 over 317. So this is the answer. 1 over 316. That is 1 as the numerator. 1 times 1 times 1 is 1, and 6 times 6 times 6 is 216. So this is the answer. Now, let's look at another example. A coin is tossed 2 times. Calculate the probability of getting 3 tails and 1 head. A coin is tossed 4 times. Calculate the probability of getting 3 tails and 1 head. Now, the probability of getting any event when you toss a single coin many times is not affected by the previous result. That means that it is an independent event. Now, if you toss it the first time, because it has 2 sides, the head and tail, these are the only possible outcomes you can get when we toss a coin. The probability of getting tail in the first time is 1 over 2. The probability of getting tail again in second toss is 1 over 2. And probability of getting tail again the third time is 1 over 2. And the probability of getting head in the fourth time is 1 over 2 also. And since this is connected with AND, that is probability of getting T, the tail, and probability of getting tail again, probability of getting tail again, and probability of getting head. This is equal to 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2, which gives us 1 over 16. That is why this is the answer. So this is how to get the probability of independent events. I say that independent events, the outcomes do not affect each other. What you get in the first event does not affect what you get in the second event. And when probability events are connected with AND, we times or multiply the events. to get our answer. So that is what we have here, and I believe that this is very clear. Thank you.